Okay, we're going to talk here about learning about standard normal distributions. Why do we want to do this? Why would anybody want to do this? Well, we live in a computer world. I can get a lot of data from the internet, surveys, books, references, measurements, etc. But what does that data tell me? Are there hidden patterns I don't see? Can I analyze it differently? Can I make predictions from it? And the answer to all of this is yes. And here's how you're going to do it. Welcome to the normal distribution curve, or the bell curve, or the standard deviation or standard normal curve. If you take a whole bunch of scores, measurements, heights, weights, IQs, math exam results, etc., if you take the number of people getting each score, they all seem to fit into a curve like this. Most people's heights will be around the average or the middle, and this is 0 here. As you get out here, you get taller people, and here you get shorter people. These numbers refer to how many standard deviations away from the mean does this happen. At 2 standard deviations, you don't have many people who are that tall, or many people who are that short. And at 3 standard deviations, you're down to only a few. So the 0 represents a mean or average, and the numbers to the left and to the right are standard deviations. 68% of the time you're going to get in here, roughly 2/3 of the score. Let's look at another way. This particular one tells you the amount of percent between each of the halves of standard deviations. So out here, after 3%, you're down to 1/10 of a percent. Boy, that's really good if you can be a 3.5 standard deviation. If you're doing projects, when you're out here, here are these symbols that we're going to be using. Mu is the mean, and this symbol is our standard deviation. So mean plus 1 standard deviation is that. Mean plus 2 standard deviations. Mean plus 3 standard deviations. A successful project out there is extremely successful or really small. Let's look at something that we might know a tiny bit about that gives you a better idea. Let's look at some IQ scores. And now on some IQ scales, we've got 2 here, the Wechsler and the Stanford-Binet. People's IQs seem to follow along the same path. 0 being the mean, and in this case, they both have a mean of 100, or an average of 100. 15 points above that is 1 standard deviation. The Stanford-Binet uses 16. We'll zero in on this line here. If I do 2 standard deviations, I get 2 times 15, or 30, added to 100 is 130. And 100 plus 3 times 15 gives me 3 standard deviations. So if you have an IQ of 140, you're way up here. Okay? And here are the symbols. A lot of times we'll use ETS-bar. Sometimes they use mu, the Greek letter. The scores will just be ETS, and the standard deviation will be this symbol. This row here are what we call Z-scores. They are the standard deviations above and below the mean. This row is the neat one. This gives you the cumulative percent of how many people get below that. So for instance, if I zero in on 115 here, it tells me that to the left of 115, that way, 84% of the data is going to be below that. So if I have an IQ of 115, 84% of the people are supposedly have an IQ less than that. How do you find a Z-score? Here's a formula. So let's try putting in 130. To find the Z-score, we have 130 is our score, and the mean is 100, and our standard deviation is 15. 130 take away 100 is 30, divided by 15, and there is your z-score right there. 130 has a z-score of 2. Now, what if your IQs fall in between 115 and 130? How do you find out exactly what that is? Okay, let's say we have an IQ of 123. So, first of all, we're going to find the z-score. We take 123, subtract 100, and divide the whole thing by 15. That gives us 23 over 15, which works out to 1.5333, repeating as a z-score. Now we could look up on some tables, but we're going to use a TI calculator to find out what actually that tells us. So let's bring in our calculator, and we're going to use this data here and these 3 commands in order to analyze it. So here's our calculator. Normal CDF is found by hitting second and var, so you get the distribution command, and choosing 2. And the normal CDF starts at the smallest number you can type into a TI, which is -1 times 10 to the 99th. And you'll find it right down here. There is the EE right above there. It comes up like an E, but on your calculator it says EE. Okay, let's put in a 1.533 here, and we'll go with a 0 and a 1. And so here we're working with z-scores. And when you do that in your calculator, this is actually what it will look like. And there it tells you that 0.93736 of the people are below that score. If I multiply it by 100, I change it to a percent. 93.74% are below that. But in order to use it that way, you have to know the z-score. So if I do it with this command right here and put in my score, I can get something without having to work it out. Let's do second distribution and choose 2. And this time I'm going to put in my score of 123 on something that had a median of 100, or sorry, a mean of 100, and a 15 as a standard deviation. Paste that in, and the calculator will work out the z-score for us, and we get the same answer. So if you don't want to spend time working out the z-score, this command right here, and I'm going to underline it. Here, I'll underline it in red. Right there, will give it to us. Shade norm is sort of neat, but you do need the command that we worked on. You do need to have your z-score. So I'm going to do 1. I'm going to put in a upper limit of 1.53333 and go down and paste that in, and there you have it, a little diagram of what that actually is referring to. At 1.533, or your IQ of 123, this many people are below you, this many people are above you. Okay, and inverse norm just does the reverse. If you put in your number, it'll give you your standard deviation. If you put in that number, it'll give you that, and you can practice with those. Thank you.